0.56.
Okay. We created a 95% confidence interval. It didn't say we had to interpret it, but I mean, what was the point if we don't interpret it in some sort of way? What do we find interesting about this confidence interval? And then let's be more specific of what I'm wanting you to say. Let's relate it back to the ho and the ha. What's interesting about the ho related to this confidence interval?
It's small.
What is the ho? What was our ho?
Wasn't it 0.358 or something?
Okay, so what's interesting about it is that our ho is actually inside this interval. Okay, so since 0.536 is in the interval, .424 and 0.56, and since it's in the interval, no wonder we failed to reject. L2 reject. So, hey, even what we just did, the chapter you just at least thought you understood on confidence intervals, it still can relate to hypothesis testing because the results we got from our hypothesis test are the same results we got from our confidence interval. And though that is not a coincidence, there's a reason there's a correlation as to confidence intervals and hypothesis tests. Does anyone know what the correlation would be? My hint to you would be to look at number 4 and then look at number 6. Where are you going?
Just say right and
Right here.
What? Yeah, they wouldn't let me. They wouldn't let me paint my face either. It's fake.
Okay, what was the coincidence between number 4 and number 6? Yeah, we rejected with both. But what was, look at the question, read through the question again, look at the numbers. What was interesting with number 4 and number 6? I mean, we keep using the same stuff over and over again. I get that our X bar and our SX and our N aren't changing because we're using the same data over and over again. What isn't it interesting that the significance level is 0.05? That alpha was 0.05. And our confidence interval, if we changed it to a decimal, was 0.95. Isn't it interesting that those two things add up to 100%? And that should always happen. So if you had an alpha level of 0.01, then you should do a 99% confidence interval. They do correlate. Okay, let's go back to your chapter 9 notes. Shalia lost hers. I gave her a new one. Does anyone else want to admit they lost theirs? I have a couple extra copies now, even though you're in AP.
No, but would you please show me which one is easy? Because I am so confused. I'm sorry.
Literally, that says chi. We hadn't gotten there. That says T. And then this one has the letter Z, this one has the letter D. It just depends on which one you're wanting area-wise.
But I think those are the line ones that you use.
Z table and the normal curve are the same thing. Same thing.
Well, my,
Same thing.
so these stars are
Yeah. Absolutely. Okay, when we last left off.
Are we putting the Skittles thing in the box or no?
No, you know how to put the Skittles in the box. You're going to get 10 points for being alive and doing Skittles. When we last left off, the dude was talking. He was on the bottom. He was on B. You can, if wanted, always finish the dude's video, and it's very likely I'm going to put the dude's video on because I just like the way he does some things. He's interesting. He's not here today. Okay, so we were ended on this problem, and we're going to actually let it go. All that changed between the two, if you were missing it last week, was that because this alpha was so high and this alpha is so low, on one of them we reject the hoe, and one of them we fail to reject the hoe. It's not a big deal. We practiced it with the Skittles, so I'm not worried about it. Let's move on to the next page. Okay, so the next page has some errors. And let's talk about the two different kinds of errors in life. So there's a type 1 error or a type 2 error. Why are you so ugly? Goodness gracious. Okay, so with a type 1 error, I try to relate it back to, I like this criminal thing we're on lately about how in guilty, not guilty, you don't say innocent the way we don't say accept the hoe, you say reject, fail to reject, guilty, not guilty. In the same way, we can do the same thing with a criminal. We could convict someone that we know is innocent. And that would be a type 1 error. In fact, it says if we reject the hoe when the hoe is true. So if you reject the hoe when you know the hoe is true, it's like when you convict somebody, but you know really they're innocent.
I mean, vice versa.
Say it again.
It's like O.J. Simpson, but in reverse.
Yes, so then so O.J. Simpson would be type 2, where you let him go, but you knew he was guilty. So if we fail to reject the hoe, but we knew the hoe was false. So again, and you do have to know the difference. So type 1 is when really they were innocent, but you convicted them anyway. And type 2 is you let them go, but really they were guilty. And I say all that to be funny, and I probably would add that to my notes. I would probably add that to my notes, but then there's something else we should add, because the way I'm saying that, as convicted even though we know they're innocent, or they're let go even though we know they're guilty, that implies we made a mistake, like intentionally. Like Kenzie decided, I like OJ, I'm going to let him go because he's a star, or whatever. And so that implies that it was a human error, and you and I both know it's a human error, we would have just redone the experiment. So it's not actually a human error. So that's the other thing you need to add. Type 1 and 2 mistakes are not mistakes made by a person conducting the test. It's not Kenzie being evil and deciding to let go who she wants and keep who she wants in jail. It's ultimately caused, as everything in stats class, by variability. The variability in the data collection process. Because we make mistakes, and that's why we have variability, and it's caused by variability. So while we were joking, and I'm going to keep them straight by thinking about convicted even though innocent, let go even though guilty, that's how I'm going to keep type 1 and type 2 straight in my head. In reality, it's not an actual mistake made by a person. This is caused by the variability of our data collecting process. Okay. In fact, the two errors have little letters going with them. If we make a type 1 error, notice it has the letter alpha next to it. And if we have a type 2 error, notice it has a beta next to it. It's the probability of committing a type 2 error. That's why it's saying P of type 2 error. The probability of committing a type 2 error is some beta. The probability of making a type 1 error is some alpha. And then they add a note that says we can only calculate beta by computing the power of a test against an alternative hypothesis. And never on power of a test. This is the first time we've ever heard that before. What is the power of a test? Okay, so we're gonna get there and we're gonna make it as simple as we can because it can get real deep, but that's meant to be in a different world. Say what now? Oh, yeah. Oh, you read it further now. Never mind. She can read. Yay, I'm glad yes, that was good. Okay, so, and I like this chart. And so if you're still like, what on God's green earth is Miss Compton talking about today? Then this chart would be what I would study. So we're hoping that if the hoe is really true, you'll fail to reject it. I mean, that makes sense. The hope is true, so I don't need to reject it. Your hoping is if the hoe is false, you know, if the P is low, you did reject the hoe. The P is not low, words.
This is getting a lot funnier, you know, the definition of hoe.
Yes, it is.
Hoe really true, hoe really false.
Yeah. So if the hoe is really false, duh, you want to reject it. It was a lie to begin with. It was a lie to begin with.
Not true.
But I like that they explain further, like if you're accepting the hoe, but the hoe is not if you're rejecting the hoe, but the hoe is really true, that's a type 1. If you're accepting the hoe, but the hoe is really false, that's a type 2. So I really like that chart. So if the above definitions didn't help you, I really think that table helps. And then Kenzie was already reading about the power of a test. So finally we get to this definition, and this is going to keep coming up. We're going to keep it very, very basic on what a power is. Because stats, especially if you got into a different stats class where you didn't eat snacks all day, stats would be, I know I'm throwing shade. If we, stats, I know, shade. Not you. I was at her with her crackers and the crunkling and the crunching and the power of a test. I couldn't hear her chewing. I'll give her that. She's a quiet chewer. The power of a test is the ability of the test to correctly reject the null hypothesis in favor of a true alternative hypothesis. The probability of this is power equals 1 minus beta. This is what you need to know. You need to know 1 minus beta, and beta will be given to you. She's annoyed with you.
She's annoyed with who?
Everyone.
That's why.
Imagine why.
I have no idea. There are more words to say about that. They're going to come out shortly. Hold on. Come on, words.
No.
Leah, do I look like I can deal with dumb stuff today? Do I just look like I just want it?
Will you please learn how to see us?
I don't know.
Okay.
But she doesn't want it to catch whatever terrible disease we all have that's making us like we are.
I'm going to stop throwing shade. No, I'm not. No, I'm not. Oh. So they say there are some ways to decrease our error, which, duh, I feel like we've always known. One way to increase error, as always in stats class, is to increase the sample size. They also say a way to decrease error is to either increase or decrease alpha. It depends on which kind of error you're making.
So could you eventually get the probability of the type errors to be equal if you increase the sample size and raise alpha in a proportion that equal the
That was
beta?
a lot of words.
I'm so sorry. No, English actually made sense at all. Yeah.
You made an effort. Alex probably did. It's when you Chicago. I said you probably did when you Chicago.
So say words again.
If you increase the sample size
Increase
to a
sample
point
size.
and you increase alpha to a point, could you eventually get the probability of the type errors to be the same?
One would assume so, but I think it really depends on the problem as to what type of error you were more naturally to lend yourself to begin with. Because stats, You know, like the OJ case. If we're relating this back to real life, like the OJ case, clearly we were more than likely going to let a celebrity off than to put them in jail. You know what I mean? Like, if they're a celebrity, it's more than likely we're going to come down a little more lenient than harshly in court. And sadly, stats is going to work out a lot the same way, in that it depends on the problem itself as to which error was more than likely going to occur. And that's my 2 cents on that.
Okay.
I like the question, though. Okay, and then I would put a little star next to where it says, if alpha goes up, beta goes down, and power goes up. And then the other one says, if alpha goes down, beta goes up, power goes down. Well, power is 1 minus beta. So if beta is going down, and this is 1 minus beta, well then no wonder it's going up, because it's 1 minus something that's tiny. But if this is going up, it's 1 minus something that's large, so it's getting closer and closer to 0, hence why it's going down. All you really, 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 really have to know is power is 1 minus beta. Power is 1 minus beta. If I can get power is 1 minus beta, then surely I can figure out how to do the rest of this. Surely. One praise. Okay, so we are, yes, dear.
So is OJ like the hoe?
Oh, his innocence would be the hoe.
Okay.
And no. Yeah. If OJ's the type 2 error. I like it. Let's do this. Let's roll with it. So the hoe is OJ innocent. So ha would be OJ not innocent. Agreed.
Would it be guilty, not guilty?
Well, are we going to say that?
No.
Or we can say guilty, not guilty. Okay. We can say guilty, not guilty, as long as we don't say, oh, you're right, I don't like innocent. You're right, we like guilty. But
Not guilty.
not guilty. We're getting very, very picky with our terms lately. It's good. O.J. Simpson. He's the one who, like, supposedly killed his wife. They, like, found gloves that are his that had blood on it, and he said he was framed. And you really need to look into this. It's like a pop culture thing you're supposed to know. And then eventually, like a few days later, he ran from the police, and they followed him. It was high-speed police chase. Yes, and then that's why the Kardashians are so famous, because Rob Kardashian was friends with OJ, and he was an attorney, so he was one of the attorneys on the case. And then there was this whole documentary about the day they arrested OJ. He had been out of town, supposedly, when it was like his estranged wife or ex-wife, they were on the outs, and she was with a different guy that also died. So, like, who else would want to kill them but you, OJ, for real? Anyway, so they were going to arrest him, and he had just come back into town. So it was like the girl died on Friday, and he's coming back into town Sunday night because he magically went out of town that weekend because he had to go. And so you would have thought they would have looked at his luggage. Well, somehow the Kardashian man snuck away with one of his luggage bags. And then when they eventually realized, like, this luggage bag was missing and they recovered it from the Kardashian man, it was completely empty. Who returns with completely empty luggage? There's a lot of fishy stuff with this. You really ought. This is like, yeah, you need to. This is one of those you're supposed to know. Yeah, they had to. I mean, then it was really hard to just have a trial at all because, again, you know, trials are supposed to like statistics, so you want to have a good jury that's not partial, and you want. But literally, it's kind of what Hunter's trying to ask. He's asking, like, what could we do to minimize both the type errors? And I'm telling him that really in stats, depending on the problem, like with this OJ case, it lends itself to a type 2 error. Yeah, literally.
I'm sorry that I brought up OJ.
No, that was a good one. It's a good reference. Okay, so, but yes, back to what Sally was saying. Ho is that OJ is not guilty. Ha is that OJ is guilty. We all accept that OJ is guilty, yet for some reason we've accepted the ho. We've committed a type 2 error. We know he's guilty, yet we failed to reject the ho.
Which was
So we said he was innocent.
Yes, we let him off. Now, meanwhile, has not the girl, but the guy's family sued the bejesus out of him, and like most of his money goes to that guy's family now. Yes, but he did not get in jail for murdering these people.
How are they able to give him a swing in the court that he wasn't guilty?
He wasn't guilty of murder. They didn't say he wasn't guilty of. I don't.
It says Nicole Simpson a
Yes.
friend. It doesn't say the boyfriend.
Maybe
One
they-
could assume. Maybe I'm making that part up, but I thought it was a girlfriend. I mean, a boyfriend.
Like being associated with the entire case, maybe.
Maybe. I don't know. Now I'm curious about OJ stuff. Mr. LeGros would know this. This is something like a pop culture thing, so therefore an English teacher's really going to know this. Whereas I am being so blind.
He looks like his. Alice
Break it like you tried to break it. Oh, don't break it.
Okay. We gotta do this one now. Okay. You read that a statistical test at significance level alpha is 0.5, has a power of 0.78. What are the probabilities of type 1 and type 2 errors for this test? So we can actually calculate the probabilities for this. Type 1, they told you up at the top, the probability of a type 1 is alpha. So we actually already know the exact answer of 0.05.
Beta is just 1 minus 0.78.
Now type 2, we discussed the probability of it is going to be type 2 error is literally beta, but we need to figure out beta. We were told the power, and we know power is 1 minus beta. So why don't we plug in the 0.78 equals 1 minus beta. If we subtract 1, we would get negative 0.22 equals negative beta. So if we divide by negative 1, we get 0.22 equals beta. Or basically, you knew beta plus 1 added up to the power. So 78 and 22, they add up to 100. That's why I knew it was 0.22 to begin with. So again, if you'll just memorize this formula, power is 1 minus beta. And if you know that the error type 1, which is we hold people in jail when they're innocent, it's alpha. And type 2 is like the OJ, we let people off when they're guilty. It's beta. Okay, and then there's another one like this. It says, you read that a statistical test at the 0.1 level has the probability 0.14 of making a type 2 error when a specific alternative is true. What is the power of the test against the alternative? Or words English. Okay, you read a statistical test. So if they asked us type 1,
Beta is 0.14, right? So 1 minus 0.14 would be the power.
yes. If they had asked us type 1, we would have said the power of the type 1. They told us that that one's going to be the alpha, which is 0.05, but sadly they didn't ask for that. Kenzie's already on the type 2. It's supposed to be beta.
Didn't they just give us that anyway?
They didn't tell us the beta. They told us the probability of making a type 2 error. So they told us the power. They said power is
Wait, no.
Wait, no.
no.
They told us the
It
beta.
says
they
the
just
probability
didn't say
of
the
the
word.
type 2 error is equal to beta.
Oh God, yes. So this would be 0.14, yes. And then they asked for the power, which is 1 minus beta. Sorry, English fun times. 1 minus 0.14, and that gives you the, did you say 0.86, right? Can my math work today? 0.86, 0.14? That's right. Yeah.
Wait, is that not supposed to be 0.01 alpha?
Yeah, I wrote the wrong thing because I'm so used to alpha being 0.05. Thank you. But I didn't even have to do that part anyway because they didn't even ask about that. They only asked about type 2. So literally, they didn't even have to tell you the alpha there. They were just checking to see, like, do you know alpha goes with type 1? Do you know beta goes with type 2? Do you know the formula power is 1 minus beta? That is the ugliest beta ever. Okay. No, they're supposed to be like the B's. It's like a B that's kind of cursive with a line down. The way I do my alpha, kind of like a fish. Yeah.
It's like half of the tree. Mine just looks like a sideways bar.
Yeah, it's just how I do my betas. You just eventually are like, this is how I do that Greek letter and roll with it. I mean, most of my teachers normally look kind of like mine. Some people get a little carried away, but who cares? Okay, let's go to the next page. And I'm going to tell you things that would hurt Louise's feelings, so I'm actually really glad he's not here to get all offended. We're going to skip this. So if you're wanting to know more about this power, more than just the fact that it's 1 minus beta, and in some way beta is given to you, that's nice. There's a really long, complicated formula for it. Go see this link. That is beyond the scope of our class. It is definitely something you would talk about in a different statistics class, not high school level, but I don't want to talk about the power formula. It is very complicated, and no. However, the guy whose video we've been watching, he does go through this example. So if you're interested in this, he goes through it just because he's a nerd like we are, and he wants to know all the things. So if you're wanting to know all the things, he goes through it, and you could go through it too. But I don't want to know those things. That's too many things, too many heads. I just can't. Okay, let's go to the next thing. Yay! Was that what I was? What was I supposed to do today? Is that fine? What's fine? Okay. No more words. Did I not give you homework for this chapter? I believe you did.
No, you gave us the warm-ups, though.
But I never gave you the chapter 9 homework?
I don't believe so.
Okay, well then let's fix that right now. Thank you for pointing that out. And then, you need to. If you were wanting to get ahead, because I'm going to hand you something tomorrow and say it's homework. You see how there are 5 steps down here? State, check conditions, calculations, decisions, conclusions, all that jazz. Your homework for tomorrow is kind of similar to that. You can go ahead and knock it out now. You have to read through an example. You have to write the ho and the ha. And you have to identify which test you will use. So if it means I'm using blank test, if it's proportions, if it means I'm using a t-test, and if it's proportions, I'm using yes, but it's normally called, no, bring me your calculator, Alex. Somebody. Hunter, give me your calculator. Alex is on it.
Huh?
Exactly. He has a calculator. So yeah, it's t-test and t-test, yes. Plus, why don't I actually look at my notes? It tells me all that anyway. So I'll hand you that if you're wanting to get a head start on your weekend life so you don't have to do this over the weekend. because I was going to pass it out tomorrow anyway. Kenzie will pass that out, and I'll give you the homework